My name is Alex Williams, founder of the New Stack, and you are listening to the New Stack Analyst Podcast, the show about at-scale application development, deployment, and management. NSX Service Mesh provides observability, connectivity, and security for distributed applications on any cloud and for any runtime environment, such as Kubernetes, virtual machines, and serverless. It simplifies deployment, upgrades, and management of service meshes within the enterprise itself. You can learn more about VMware and its service mesh at vmware.com. Good morning, everyone. How are you? How's everyone doing? How's KubeCon going? Going well? All right. What an event, huh? I don't know if any of you have been to KubeCons before, but with 12,000 people, it's kind of a whole new dimension to what has emerged out of this community and what we're seeing just in terms of the architectures and the tooling and everything else. And our discussion today is about service mesh. And before I get started, I want to give a big thanks to VMware for sponsoring this breakfast. Let's give them a big hand. And I want to thank all of you for coming out this morning. And we love our pancake breakfast, and it really is an opportunity for you to ask questions and for you to really get involved in a discussion. These people are real experts in the space, and they have a lot to share. To offer a little incentive, we do have a Lenovo Bluetooth speaker to give away. And so if you ask a question, we will give you 5 additional tickets. And so that's the incentive that we can offer. I also just want to give a little bit of an overview of the New Stack. The New Stack is a research and news organization. We are recording this discussion today, and it will then be posted as a podcast after the conference. And so you get a chance to come back and look at it and watch it if you wish. The New Stack really looks at these issues that relate to explanation and analysis of at-scale development, deployment, and management. We started covering the space in 2014 with a focus on container technologies. And the reality was at that time that Docker was becoming a symbol of this new world. And we've seen so much change since then, and now Kubernetes really has become a symbol of this new world. But there's lots that has happened along the way. And one of the things that's come along the way is this move from architectures in the data center to architectures in AWS or any other infrastructure as a service. And now we're into a new dimension, and that's the dimension of a world that's built upon dependencies. The complexities are enormous. And so for today, we really want to focus on service mesh. And so we're going to be looking at the discussion in three ways. We're going to look at the basics of service mesh, so just going to giving us the underpinning understanding, finding out what users are saying about service mesh. Secondly, security. Security is a big issue. And thirdly, the tooling. So before we go any further, I'd like to introduce the people on our panel today. And why don't you each introduce yourself?
Hi, I'm Gina Telsic. I'm an analyst at 451 Research, working in the digital economics unit and also focusing on the economics of cloud-native technologies.
My name is Wei. I actually joined Uber fairly recently. I previously worked for VMware. So being able to see both sides of the world, vendor versus consumer, is my dream. So I'm doing my dream right now.
Right.
Hi, my name is Fu Yuan. I work for Pinterest, and specifically our team is called Infrastructure Engineering, and my team is dedicated on service mesh. We are meshed by Pinterest microservices. And before joining Pinterest, I worked for Uber almost 2 years.
Hi, my name is Lita. I work for Lyft. I am the tech lead of the networking team, which owns both the front proxy and the service mesh.
And my name is Per Monclús. I'm the CTO in the Network and Security Business Unit at VMware and working on connectivity technologies.
Hello, my name is Ines Envid. I'm a product manager in Google, and I've been focusing a lot on networking, security, and kind of the evolution of the models to microservices and service mesh.
And we have Job Jackson, managing editor of the New Stack, with the microphone. I do encourage you to tweet, to take pictures, to share the experiences here. We love to have that conversation and dialogue. So let's just get started. I want to ask the panelists, and we have a mix of people here, and I'm interested, from an economics point of view. I mean, what are the user reasons for adopting service mesh technologies? I'm very curious about this from the 451 research point of view.
Well, I think from an economics point of view, the whole notion of connecting microservices and breaking down monolithic applications into smaller services and connecting them, the economics of it are very compelling, not just in terms of how to, how the operations, how much more quickly you can iterate the applications, but also the infrastructure costs tend to be lower than what we're seeing with traditional applications.
Okay.
So.
Yeah, and to add to that, I believe that what's nice about a service mesh is that since there's only one piece of software running across all your microservices in a uniform way, you can embed all your networking expertise into that piece of software. So when you implement things like retry policies, connection warming, all these like networking specific things, you only have to do it once versus doing it for every single microservice.
Per?
Yeah, I mean, we always focus on the agility aspect in the sense that we have to secure and connect applications. And now when we bring a technology that gives strong identities with certificates, end-to-end encryption, circuit retries, circuit breaking, and so on, what happens is that we are elevating to a communication level that adds different types of value, and as we were pointing, in a single control plane without having to spread across multiple applications. So the fact that we are unifying it and essentially bringing a better agility from an application point of view, but preventing mistakes. I mean, because we always focus on agility, but we have to remember that agility is not the only thing we want to do, is we want to prevent mistakes.
Is that what users are asking about, though?
Yeah, it's the notion of bringing the security aspect on communications in a way that now is not just about breaking the architecture from monoliths to microservices, but it's about now how to connect them and how to have security models that they understand and they control end-to-end. And when you bring the two things together, is the agility plus the security combined in one solution.
Yeah, so the interesting part with kind of the service mesh is like when you actually go and talk with, kind of the users and the enterprises, there's always, actually the service mesh models have been there even before it became a thing, like because the paradigm, it was about having developers and operators of the services been really kind of having an abstraction in which they operate their services in a way that is a little bit abstract from the infrastructure itself, and that is really exposing endpoints for traffic management, being able to understand which services are talking with another services. I think the nice thing with, which is the security aspect of it, so there's always been this need, I think recently with the transition from monolithics to microservices, really that trend and the needs for service mesh, it really grows because kind of the need for connecting a lot more different services and endpoints, it has exponentially grown, and that is where really the operational models are really compelling from velocity and security aspects, and kind of unifying that is become a very interesting conversation.
Yeah. So I wanted to add, actually I want to back off a little bit, just look at cloud native. So what cloud native is really about is not really running on the cloud, but rather than exponentially exploring the capabilities of the cloud. So in doing so, cloud microservice architecture is just mandatory, it's just necessary. So when you go to these microservices, you very, very literally just, if you draw a graph, you just have to end up with the service mesh, this kind of architecture. It is a framework, it is architecture. So in order to deliver this architecture, you can do different things. You can still do library integration. You can still do a node agent level integration, and eventually get to the mesh kind of world. So this is really just the what that we want to achieve and the how. This really just derives the how. Actually, at Uber, we are actually really experiencing these kind of fundamental changes. So essentially, Uber's microservice has gone through 3,000, 4,000, 5,000. I can imagine as we light up more business lines. There's 400 million rides on this platform. So essentially, this requires us to iterate fast, making sure anytime we deploy, we cannot break anything. The riders has to be able to request a ride. The drivers has to get money in their bank. So there's really this kind of real-time association requires us to move fast. And one of the fundamental things about a service mesh is really the role clarity. The service owner versus the platform owner. Each of them iterate differently. The contract is there. So that is kind of my personal understanding for this whole thing.
So what are the requirements of Pinterest?
Oh, okay. We actually have a very solid use case. So we have hundreds of services and thousand level clusters, and we do continuous deployment. We deploy a new build every 30 minutes, and we previously see the SIO actually drop a little bit when we do deployment, and then we just switch to a service mesh architecture. We use Envoy to do this health check. And then we solve the agricultural user to solve the problem. And also we have another requirement is security. Due to some compliance requirement, we need to enable MTLS between most of our services. And we have a lot of languages. We have a lot of platforms. We run on AWS VM. We run on Teletron, which is our in-house deployment system. We run Kubernetes, and when you connect them, there are some difficulties, and we actually use service mesh to unify them. That's our use case. Yeah.
Excellent. Okay, so let's get some questions from the audience. Anyone have a question? Okay, we have one over here. And just state your name and your company.
Hi, good morning. My name is Sahil. I'm from Salesforce. I wanted to get your thoughts on what are 3 ways you can get the service mesh deployment wrong?
Good question. Is it Kubernetes first, or is it the service mesh? And that's, I think, the question. Maybe that
Maybe
part of that.
So we were discussing this in the table with the panelists before we started, and there was this question: is it first the Kubernetes cluster or the service mesh? And this is like, okay, what's first, the buying a switch or buying a server? It's like, well, you need both, right? So the thing is, what does the service mesh bring you that that the previous ways of connecting containers would not be able to do it, right? And if you think you could connect based on IP, basically you could send packets at the networking level. But based on the things that we've been discussing here, what you see is that the service mesh gives you much more, in the sense that gives you what's the application health, because now I see the end-to-end transaction time. Now, based on that, I can see how to scale applications. What's the back pressure that I'm getting from a service, and maybe I have to have circuit retries. What's the end-to-end connectivity, and now I have the security. So as we start thinking that service mesh is essentially a connectivity layer for microservices. Now it's like, what's first, the connectivity layer or the microservices? Well, probably you need both. And now you go to the next level and you say, well, am I going to have a single cluster or multiple clusters? Because if I have multiple clusters and now I have to connect them, am I going to now configure VPNs and firewall policies and things like that in order to communicate from one cluster to the other? And now you go externally to your cloud native or your Kubernetes infrastructure, and now you have to start opening tickets in the infrastructure layer in order to make that one microservice in one side connects to the other. That's quite painful. So now it's like, why not a service mesh that end-to-end with MTLS and everything connects from one cluster to the next? So the way we see it is that as we evolve into this cloud native journey, the capabilities in terms of how the compute form factor with containers and pods and so on is changing. The connectivity needs are changing too, and service mesh is this connectivity layer that essentially allows you to connect all your microservices across any cluster. That's why a lot of people start with Kubernetes because it's the obvious thing. I mean, you get the containers as a service, you get the pods, but then you say, okay, so how am I going to connect multiple of them? Then the other thing we see is that people say, oh, I'm going to create a cluster with 10,000 pods. And my feedback to that thing is like, this is an anti-pattern. Now you're creating your biggest pet ever to handle your cattle. So why not treat the clusters more disposable? And now with service mesh connecting across multiple clusters, then you can create things that are more manageable from an operations point of view.
Lita?
Sure, yeah, so Lyft has a different history since we were a service mesh first before we ended up going to Kubernetes. And so our deployment is, again, it is pretty difficult. Now that you have the software shared everywhere, now it's very dangerous to roll out. So that's a very good question. What we do is we have different environments. So we have like a smoke testing environment, a staging environment, and we roll out, let's say you're rolling out a new Envoy binary, we would be rolling, since our legacy stack is in virtual machines, we leverage Envoy's hot restart infrastructures in the legacy environments and roll it out in gradual steps. And it's not fast. It does, in a happy path, it takes about 2 to 3 hours to roll out a new upgrade of Envoy. But the thing is, Envoy has a lot of metrics and stats to show you if things are working, and you could relatively see pretty quickly if something's not working. And anytime if there's like an incident, or like a case that we realize that the metrics didn't show, we add that to our testing framework, or we add that to we add it to our dashboards to make sure that we can monitor for that if we can't automatically detect it. So I agree that deploying into the service mesh is quite difficult and risky, and there has to be a lot of infrastructure and oversight to make sure that that rollout process is smooth and safe.
Ines?
Yeah, so we've actually seen both journeys, and it's interesting to see how different enterprises are going through the transition in different ways. We're totally seeing the journey for, before going to Kubernetes, having the need for the basic kind of security in dev with authentication of services, MTLS encryption, understanding what is happening. But I think the most common pattern is actually a path in which really the transition towards Kubernetes as kind of a way of evolving to a microservice architecture is actually, again, exponentially exposing the need now for having more control over how these services communicate, how they actually authenticate. So I think the journey towards Kubernetes is actually kind of goes together with usually the need of having more control because there's more services granularity. And the other piece as well is it gives as well a very good point for having a better lifecycle management of the Envoy proxy itself, so kind of the managed control plane and the declarative model. It gives you a very good starting point for actually deploying the mesh, which is actually helping customers to make that transition easier. So I think those are the reasons in which those things usually go hand to hand, but we've totally seen those being separate as well. But again, the pattern that we see most is really that they go together for the reasons that I mentioned.
So they go together.
Usually, like not always, but there is a correlation that I've seen in how enterprises are evolving, in which usually the evolution to Kubernetes is actually exposing the needs of the service mesh, and it actually provides the opportunities of having a managed service mesh that it's harder with kind of the infrastructure deployments that were available at that point.
Should they do it all at once, or?
That's the part that I think it really depends on the enterprise. I know that's not an easy answer, but I truly believe that kind of the conditions for different enterprise and where the development teams are vary a lot. But I think looking at the opportunities that both technologies give you together, it is a good way of approaching the problem.
At 451, what is the feedback that you're getting from, about Kubernetes and in service mesh, and which comes first? Do you have any recommendations?
I agree that I think service mesh and Kubernetes sort of go hand in hand. What we've seen is that people are very guarded. The promise of service mesh is great, but I think what the question reflects is that it feels very brittle when you're, applying all of these policies. There are so many places that, things that can break. And whereas when you had a monolithic deployment every quarter or something, and you would worry about that breaking the system, if you're deploying, every 30 minutes or every few days, it just, I feel that there's a real hesitation about starting on the wrong path and, how to introduce it, and that once you start on the path, it's a big investment of time, engineering, and there's a risk. So.
Anyone else like to add anything?
Maybe on this comment about the risk. When we were deploying applications every 6 months or every year from a monolithic point of view, you do proper risk management, you do change management control, you do windows at night that you are going to essentially configure the firewall policies, the VIPs and so on. And that, when we say that enterprises need to become more agile, it's not possible anymore because we have continuous delivery pipelines that they are going to upgrade. So even if there's a perceived complexity and brittleness and so on, the question is otherwise how do I do it, right? I mean, the notion of configuring firewalls, configuring policies manually, virtual IP addressing, load balancers, DNS names, and having a set of tickets that are going to be executed by humans on a human scale, it's becoming obsolete.
Great.
And that's why we have to transition to Kubernetes, service mesh, and so on to give you the agility. Now, as any new technology, there's a requirements in terms of training, understanding how to use them in a way that the brittleness is more like when something fails, how do we roll back, how do we troubleshoot? And that's where the need for talent and expertise appears, and from solutions that essentially simplify the deployment and the operational aspect.
So at Uber then, what have you learned in your own experiences with service mesh, and what advice would you give to Salesforce?
Well, we probably also need advice too. First of all, I think we are actually, Uber has built the stack, very deep stack, a lot of proprietary technologies has been built in that stack. However, I do think Uber, because as the platform, as Dara's vision about the platform being the core, and that platform can enable multiple business, so that platform has to be built, validated across the different clouds, so that, and also that platform has to grow very organically. So the directions that at Uber we see, yes, we are going to Kubernetes, we are going to service mesh, but how is very challenging. And it's actually a very, very challenging problem for the company to be very sustainable going forward. A lot of very good engineers, they are taking this problem very seriously, but I also can see the trend. They have to go hand in hand. So the service mesh makes assumptions on the platform where the microservice runs. That assumption you can tweak, but I think in order to align with the open source community, with the standard, with the framework, I think certain assumptions you just cannot change. So that requires these two things to go hand in hand. So we are learning. So that's why we are also here to share our experience and also learn from others, from, for instance, Lyft, to making sure that we can run these things for our drivers, riders, because it does make impact for their daily life.
Yeah, I do agree that they go hand in hand. Lyft's journey is a little unique, where we were the service mesh first, and then when we migrated to Kubernetes, that was actually, we leveraged the service mesh because that was a network primitive that all microservices understood, and we were able to ship traffic gradually to our new Kubernetes cluster. And now our deployment's a lot more dynamic because in Kubernetes you could feed, like with readiness probes, what does healthiness mean? And so you can easily stop the deployments versus someone manually watching something. Like you could go towards continuous deployments with a Kubernetes platform. And so I agree that they go hand in hand. Our journey was that we went to the services first and leveraged it to do our migration over to the Kubernetes cluster. But I agree that it depends on what your infrastructure is and what kind of path you go for.
Great. Let's get some questions. Are you here? You have a question?
Hello, my name is Robert. I'm with a small startup out of Denver. Hearing you talk about how your companies have been investing in building out the service mesh architecture, does the learning that you have imply that this technology is ready for a small company? Or is this something that you need to have already hit a certain scale for it to be worthwhile? And then a follow-up question to that is, does that imply that you're always going to have a legacy migration to unengineer what you had to build to get your company off the ground?
Yeah, that's actually an excellent question, and I think there are obviously maturity of these technologies. Right now, I think the technology itself, it is ready. I think the managed services and kind of the managed solutions that are provided in the platforms are the ones that are maturing. And as you can see, through the ecosystem, there is so much focus investment in the industry to bring it to a level of maturity that is ready for any small enterprise to adhere. I think the answer to your question, at least specifically for what I've seen, that it's available at Google, we are actually in the process of integrating all the managed services like the load balancers, the certificate authorities, everything as a managed service as part of the single mesh, and then bring deployments that are able to do traffic management across multiple clusters, that are actually able to enable a transition and a migration from VMs to Kubernetes. Some of the restrictions that you see around the managed solutions for those deployments are still there. So I think there's going to be, in the next year or so, really what you're going to see is that technology is going to become ubiquitous around all these type of deployments across different environments, across different type of infrastructure. So I will say it very much depends. So I think it is ready for some type of deployments. I really believe so. I think in the next year you're going to see a tremendous kind of evolution and acceleration of those for now every type of deployment.
Fion?
Me? Okay, sorry. So I think if you are a small company, you can probably start with Istio or some existing service mesh and see whether it meet your requirement. But if you are a big one, like not necessarily very big probably like us, at least 2 years ago when we investigated the service mesh, we found that the existing solutions somehow don't meet our requirements, and we had to build our own. Just like what Leaf said, we built our control plane on top of Envoy. So after 2 years, there were a lot of work done, and we had to work with the community very closely. Sometimes we are very brave. Our data plan, which is Envoy, is nearly sync with the head of master. And we frankly see the problem. Of course, it also solved the problem fast, but there's a work. And today, if you build your control plane, even if you are make it work with Kubernetes, there are still a lot of work. And make sure that you are ready for that before doing that. And For a small company, I really don't encourage you to do that.
Yeah. I echo what Fuyan said. It's a lot of work, and you have to justify that work with like, are you at that scale? Is your monolith blocking your quick iteration deployments? Do you already have product market fit so that all your teams are blocking each other, so that you need a microservices architecture? If you're still a small company, still need to defining what your product is, and you need to quickly iterate. Not sure if a service mesh with microservices is the right architecture for you.
I just got to say, I love this. Like, Uber helping Lyft, Lyft giving advice to Pinterest and like to the rest. This is awesome. I love open source.
And maybe I'll bring another take. Your question is about is it ready, right? And we always discuss what the technology, the operational model, the consumption model, and if you think something like Kubernetes, is it ready? Well, are you going to pick it from open source? Are you going to buy it on-prem from a provider? Are you going to go to a SaaS model? Because this will dictate, do you have to take care of the lifecycle management? Do you have to take care of maintaining it, upgrading it, and so on? And service mesh is exactly the same. First is like, is the technology ready? Yeah, we've seen like at large scales, at small scale, the technology being deployed. Now, are you going to take it from open source, manage it yourself, install it yourself, push YAML files? Do you want an API model? Do you want a SaaS model? And what you're going to see, and here you have the different spectrum from do it yourself, kind of like starting from the raw components and building a solution from scratch, to vendors like Google and VMware that with different operational models, different consumption models, are going to make it easy to consume. So I would say like with Ines is like, yes, it's ready. Now the question is, based on the option you choose, your level of engagement will have to be different.
But how could you even manage to do this kind of work concurrently? I just can't even understand that. Like, Kubernetes is complicated as it is. I mean, I was speaking to a well-known analyst yesterday, Johnny Kiram, MSV, you may know him. And Johnny's like, listen, like just the developer alone is trying to put together all these pieces when they're using a Kubernetes environment, and then you actually then have kind of the people who are configuring Kubernetes, and now we're not even sure who actually should be configuring Kubernetes, whether it should be someone in IT or even the developer themselves through YAML. And then on top of that, you have isolation issues, and so then you add service mesh on top of that. I mean, I like the Lyft idea. You did service mesh first, but you didn't have Kubernetes at the time. So anyway, that's my thought. But any perspective on that, like on this idea of doing it all at once?
Kubernetes or containers as a service is kind of an evolution of infrastructure, right? If you say that the developer has to create its own clusters, maintain its own clusters, operate its own clusters, install Istio and Envoy, it's crazy. The developer should be like writing code and creating new value. So that's why the value creation point of view should
It's the value creation.
Exactly. The developer should take care of the value creation. Now, how to maintain a Kubernetes cluster, how to maintain a certificate authority, how to put policies, that's somebody else. Now, is it the platform group? Is it infrastructure group? Is the organization where you live capable that infrastructure team is growing to that, or that the platform team is going down? But definitely the developer should not be maintaining the stability of a Kubernetes cluster.
Any questions?
My name is TJ. I work for Space Dynamics Laboratory, and one of the questions that goes along with should a developer, be managing your Kubernetes cluster is the service mesh. They tout that it's Polyglot, and we have, we work with different groups all across the country, and we really like them to, submit algorithms as code and have it run within our system. And this service mesh looks like it would be a really good way to do that, but then protect the system if we do need to overhaul security or how we're moving data around. And my question to you is, does it really work? Have you really seen that effect where you've got Polyglot, where multiple people are contributing, and the service mesh actually works?
This is a good segue into security questions.
I could speak to the Polyglot architecture. So yeah, Lyft runs 5 different languages on their service mesh, and we use protobufs and tied with service mesh to make sure there's a type-safe API that our microservices all adhere to, and we use code generation to create that boilerplate like protobuf data structures. And so that's how we make that work. But yeah, I agree that like making Java applications talk to Python applications, very hard. But like, since like there's a proxy that they all, the proxy all like is the same across the network, and there's a concrete API contract, that's how we get that to all work together at Lyft.
What's the Uber experience?
Uber experience.
Yeah, I like that.
Okay. So as we all know, Service Mesh delivers certain functionalities. Security is one of the predominating use cases, right? So at Uber, we are still doing this work, and we are actually adopting this. So first of all, let me back off a little bit. So when we talk about identity, the standard specification of that identity is very, very important. So luckily in the cloud native CNCF, we have the SPIFFE standard. I cannot say how much I respect their work. They are advocating for the standard around the cloud native because that is very, very important. First of all, you have to have a standard because you do have a very concrete problem you have to solve. So as along the side, SPIFFE, that company also come up with a Spire implementation, runtime implementation. That is what we adopting at Uber. So one of my tech lead engineers is actually one of the maintainers for that upstream project. That project is not mature yet. So we are upstream a lot of things, making sure it can be scalable, it can be reliable, and we can run it in production. Now the second question is really the granularity of that identity. So the granularity can be across the cluster, across the node, across just really, really specific microservices. So this is all, a lot of complexity actually goes into really just delivering that identity, the backend work. Now it comes to the service mesh, how you actually deliver that contract to the workloads. That is actually, I think that is your fundamental questions here. It's not going to be easy, first of all. So we are still experimenting. We are actually taking our very, very concrete step. One of the things I think I want to share is really when you actually want to institute a very strong identity in production at scale, where you have a proprietary stack, the approach you probably want to take is really incremental. Light up certain use cases first to make sure it actually works end to end. That is really, really important. One of the blog posts I would recommend, which is not specific to security identity, but it's really how the company Monzo Bank, I think everybody should know, Monzo is a European bank. It actually really so it has a huge presence in the cloud native. I really like their engineering principles. So they light up some very, very critical business lines end to end, doing the service mesh, doing the network policies, working with the service owner as well as the platform owners. And they actually tweak a lot of like concept, role clarity and stuff along the line. So light up very critical business lines first, end to end, and then you can actually adopt it more broadly. So yes, identity is a critical thing at Uber. We needed to do the right thing for our consumers. So we are still learning our way. And this architecture, Spire architecture as a framework, it can work because its fundamentals, philosophy is right. It has been proven in our environment. We deploy multi-cloud. It has been proven just not one cloud, but multiple clouds. So it can work, but there's challenges still.
Right.
Yeah.
Questions? Any other questions? Love to get some more questions. And feel free to reply to anything that you heard too.
I'm Pawan Sura from VMware. I would like to hear some thoughts from the panelists on adoption of Kubernetes in IoT and maybe service mesh. IoT world.
Service mesh and IoT. I would be curious on I wanted to talk about security, and this seems to be one of the big topic around service mesh and IoT.
It is a super interesting area. I just gonna say, and there's a lot of different areas that are intertangled in that conversation. I think something that is really happening in the industries with the evolution to 5G, really the architectures to the wireless 5G, really the architectures that were built more on the traditional interfaces like GTP and diameter that were really not, that couldn't really plug very well into these new architectures are really being replaced by interfaces that are more industry standards and based on gRPC and based on HTTP2. So that is giving kind of a tipping point for rethinking kind of how the deployment of these edge functions, that it could be IoT, it could be 5G, are being redeployed at the edge. Also kind of the distribution of this is becoming more prevalent. So that leads to really the needs for authenticating not only services, functions, but also endpoints that tied very well to the service mesh conversation. Having said that, I think this is like really an evolving conversation in which I feel that actually in the very short future, these conversations will merge somehow, and it's going to lead on some new edge architectures. I think it's a lot of going on.
Gene, I'd love to get some feedback from you on this topic. I think you probably are looking at IoT and all the kind of associated issues with it. In terms of service mesh, it seems like service mesh is an extension into new realms. It basically takes the concepts that we know, that we see through the services that people are using, they apply in many respects out to IoT.
Right. Based on my understanding, service mesh and IoT are a very good match in the sense that you do need a lightweight way of identifying and authenticating traffic coming in from sensors and so on. So that's...
Maybe we are discussing two things, right, when we discuss service mesh, and maybe tying it to the previous question. I like what Lito was saying about, okay, what is service mesh? Service mesh, we are going to create a pattern that we put a sidecar, that we proxy HTTP, gRPC, whatever it is, MQTT, and now we are going to essentially start like connecting at that level, and I'm going to be able to do routing based on the protobuf, based on the API, based on whatever. That's one aspect. The other is I'm going to assign a certificate to that entity, and I'm going to have an end-to-end MTLS encryption. Now, when we discuss service mesh and IoT, there's two things. One is, can I manage the identity of the IoT devices in the way that now I assign a certificate, and I have an end-to-end mutually authenticated session with whatever service you may have in your Kubernetes clusters. Check. Good. Now, the next is, what protocols are you going to run on that IoT device? Is it going to be HTTP? Is it going to be gRPC? Is it going to be MQTT? And now it's like, are you going to have the plugins and the capabilities in the service mesh to do useful stuff in terms of traffic steering, layer 7 filtering, policies, pushbacks, and so on? And the third, going back to the previous question about if service mesh is ready for the computation thing, going to what Lita was saying, then is, now, what's the schema or the message schema that I'm going to have between my IoT device or my calculation application to my other application? And we have to think that if we don't define a mechanism that, imagine that the service mesh allows to talk between a person in China and a person in the US with an encrypted communication and so on. But if one speaks Chinese and the other speaks English, they are not going to understand each other. So that's why when we say service mesh for IoT, it's like, can I extend the encryption end-to-end? Can I do the certificate management? Can I do the traffic routing? But then the next is like, what schema am I going to use and what language and meaningful things am I exchanging through those protocols? And that's why there's multiple layers that when we define applications in microservices, we have to take into account, because service mesh is not going to solve all these problems. It's going to connect things end-to-end with encryption and so on, but now the coherence of the microservice understanding each other is a layer of a boilerplate of Google protobufs or whatever it is.
Yeah, and I mean, all those cars essentially are data objects, right? And so the concept really applies to ride-sharing services.
Yeah. So Matt will want me to plug this, but Lyft is thinking about things like this, like how do we get Envoy to our mobile apps or to our cars, and Lyft has invested in working on Envoy Mobile, which is not a proxy, but it's a library that you can embed in in your like mobile device or your, in theory, I could imagine like you embed a lightweight library in your IoT device. And so we are like, I think that is very brand new pioneering technology that I do not know as much about, but like that is something we are investing in and trying out. And I think we want to be able to take all the benefits of the service mesh, just as like, such as like, authentication, and stats, all this network logic into a lightweight library. It has to be different because the requirements on the phone and IoT devices and cars are different. Like it has to be more lightweight. It has to send a lot less data. And so that's still being figured out, but it is something actively being worked on.
All right, we have a time for a last question. Do we have anyone who would like to ask a question? We have one.
So,
Can you tell us your name and who?
yeah, I'm Michael, and I work with the government. And I just want to know, how many sidecars are too many sidecars, in your opinion? Because I've had a lot of sidecars before, and I've heard a lot of different answers about that.
That's a good question. Yeah, I think there is a limit. We at Lyft, we try to limit them as much as possible. We currently have 5, and I think that's still a lot. But I think there's interesting work that's going on where like how do we create, maybe not use a sidecar but make it into a daemon set, but then you add more complexity. So it's a trade-off. Like ultimately you're using more resources, but it's a lot more simpler to manage versus, and like if it is hurting your performance, like you want to reduce memory and costs, then you have to add more complexity to. So I think it varies depending on what your infrastructure and your cost requirements are.
What's the Pinterest point of view?
Yeah, I actually kind of echo Lita's idea. So it's actually a balance. So in Pinterest, we actually typically we have about 10 sidecars plus the major one, and there are a lot, but they use very minimal resource, and the benefit is you have a different environment, and each sidecar belongs to each different environment. You can get the deployment separate. You can separate the deployment, and you can isolate the issues, and that's the benefit. So it's at the end of the day, it's just a trade-off. What do you want, right?
Maybe the question is how do you control them, right? Because you're going to have, for example, in your Kubernetes environment, at least one type for east-west, potentially one north-south that is a little bit more capable with WAF capabilities, things like that. Then when you go into your VMs, you may decide to do it with a traditional load balancing proxy, or to put a library, or to put an agent, and then you'll have like going to the cloud, serverless, things like that. So the sidecar is going to be a function of the technologies that you have behind. And as such, having an Uber sidecar that can, sorry for the Uber, a sidecar that essentially solves all the use cases then becomes a big complex project. And if one is for VMs, the other is for containers and so on, it's easier to manage it. But at the end of the day, it's like, how do you operationalize the life cycle and the management of those? If you can unify that, then it should be abstracted.
Yeah, so,
No, I just wanted to add to that, because I think that's a very important point. I feel is kind of the key to the question. I think there's 2 aspects to it. One, it's obviously like if you're talking about chaining, and there is obviously some performance hit that you take on that. But if you're talking about, how many flavors do you use in your deployment, I feel it's very important. Like it's even more important that do you actually have a standardized interface that you actually have northbound, in which you're actually seeing, like you're pushing policies the same way, you're actually doing the traffic management the same way. And I think, for example, with the XDS interface, with Envoy, that's been really critical to really kind of standardize that interface. So at that point is the lifecycle management of it, but really operationally for your developers, they're not going to actually pay the overhead for having different types.
yes, I just want to add something. At Uber, I heard engineers say, hey, just get a sidecar in. Everything will be solved. But I think you really need to understand what problem you are trying to achieve. Sidecar does come with a cost. So I think some of the principles, best practice I follow will be there's default sidecars, for instance, delivering the identity, those kind of things. You just probably have to have it, and it should be made a company-wide standard. But for certain use cases, you probably have to customize some of the sidecars. However, the way that you manage sidecars, that process can be also standardized. So there's different ways that you can trade off. It is a trade-off. But when engineers say, just get a sidecar in, but watch out for that.
Great.
Do you really need it? Yes.
So I would love to get the 451 wrap up today. What have you heard here today from everyone that gives you some kind of perspective? This is where we're looking for that analyst perspective. What is it that you're and also in the context of what you've been hearing up to this show?
I would say that there is a lot of promise, but also a lot of trepidation about adopting service mesh, how to go about it, and how to, have that sort of nirvana of the unified management layer for the microservices architecture, and that some very big and important cloud native companies are doing it in production, and it does work. So
It does work. Great. Well, okay. Well, let's have a raffle. It's time to pick a ticket and get your tickets out, because you could win a Bluetooth speaker, waterproof. You can, I don't know, you could go for a swim off Coronada.
Do I say the last three numbers? Or?
You can say all the numbers, yeah.
Okay, 703388.
703388. We got a winner. See, he asked a question. All right, well, thank you all for coming. Let's give a big hand to VMware for sponsoring this pancake breakfast. NSX Service Mesh provides observability, connectivity, and security for distributed applications on any cloud and for any runtime environment, such as Kubernetes, virtual machines, and serverless. It simplifies deployment, upgrades, and management of service meshes within the enterprise itself. You can learn more about VMware and its service mesh at vmware.com. Listen to more episodes of the NewStack Analysts at thenewstack.io/podcasts. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.